Hi, I am going to demonstrate our sensor cloud. So we have created a sensor cloud in which we have taken a couple of physical sensors from the west coast of California, and we are getting some sort of temperature, waves, wind directions, barometric pressure, those sorts of data here. So this is our login page for sensor cloud. So I have already registered with my username and password, so I'll just directly go ahead and log in. So once I log in, this is my dashboard where I can see all these sensors. By the way, these are not physical sensors. These are virtual sensors which I have already created. So I'll just go ahead and show you the demo. From here on the left hand side, we can click virtual sensors and we can click add. I can name my sensor as my demo sensor 1 and description as project demo. Now this virtual sensor has to map to a physical sensor. So we have list of all the physical sensors which are coming from the west coast of California. So let's say if I select a water temperature from Maria, I'll do add virtual sensor here. It will redirect me to the list virtual sensor page and I can see my demo sensor here. By default, this sensor will be in off state, just like as a EC2 machine. So I can turn it on by clicking on this off button here. So this will just toggle the status of the sensor. Once I click it, yeah, the sensor is on. And if I click it again, the sensor is off. So let's check the health check module of the system in which we can check the health of a sensor. So if I go to health check, it will list all my sensors which I have created and their status. So as you can see, there are few sensors which are working fine. There are few sensors which are not reporting data. It often happens sometimes these coastal sensors which are deployed on the buoys which are in the water, they don't report data on time. So we see a lot of lag around like 5 to 10 minutes or 15 minutes or even up to 10 hours as well. So as of now, these sensors are not reporting any data. Few sensors are reporting, and the new sensor which we have created, that is off right now. So what we'll do is we'll go to list sensor and we'll turn it on. Let's go to dashboard now. Once we go to dashboard, we see our Santa Maria sensor as well. Probably this would be the one. Yeah, see, Santa Maria, this. So since we are collecting sensor data periodically and these sensors sends data at a 2 hour frequency, we haven't got any data for this sensor yet. But if you look at other sensors, we see data for those sensors like water temperature, value, what unit they are showing. If you go a little down, you'll see wind, wave and height. So these winds are like 0.4 meters high. And this is the timestamp when the sensor captured the data. Apart from this, we also have implemented a physical sensor which we have built on top of Raspberry Pi 3. We have integrated a temperature module with our Raspberry Pi. What that Raspberry Pi does is that Raspberry Pi sends data continuously to a centralized location. So for now, if you can see, this is our Node.js server which is hosted on IBM Bluemix, and Raspberry Pi is continuously sending data over here. See, the new temperature entry appears here. And on the map, since the Raspberry Pi is in the Bocardo building where we are having the presentation right now, so if you click on this pin here, we'll see sensor is T1 sensor from SGSU, parameter temperature, value 22 degrees Celsius inside the our Bocardo hall, and unit is Celsius. And this is the timestamp at which, this is a UTC timestamp at which the temperature is being reported. So similarly, we can even create n number of virtual sensors and map them to a physical sensor. So let's say virtual sensor demo 2 description blah blah. I can even map it to my Raspberry Pi physical sensor, which is right here. If I map it, then this sensor will also start getting data from our virtual sensor. This system we have deployed on AWS Stack, so I'll show you a little bit about that as well. what we are doing is this web traffic which is being served on the sensor cloud is being served by a couple of EC2 machines. For now you'll see only one machine, but as soon as the load will increase, the load balancer will start invoking the auto scaling groups and they'll spawn new instances. So we have created an auto scaling group where the desired is 1, minimum is 1, maximum is 4. So if we get a traffic spike, which I can show you from JMeter in the demo, we'll see a couple of more instances here which will spawn automatically. Apart from this, this is just the web traffic serving part. The database part we have hosted on AWS again, but that is again a different MongoDB cluster, so that is again a scalable solution there. So yeah, that's all from the demo. Yeah, one more thing, this system is multi-tenant as well. Since I'm a user, I logged in with Ritvik, I can customize the look and feel of my system. So I can change it to mint color, and then I can go to list sensors. All the theme will be intact, right? And then I go to blue color, this will be my color. So this is a multi-tenant system. Every user can set their own themes. One more module I missed in list sensor. I haven't shown you how the data is being populated in the table. So let's go to this new sensor which is on and which was in fine state, fine health as well. Once you click on that center, you'll get a huge list of parameters. So these are the parameters this particular sensor is covering, value along with the unit. If we just want to see, let's say, water temperature data, you can filter it from here. See, you only get water temperature data. If you want just wind speed, you can get wind speed from here. Things like that. You can increase the number of entries if you want. So we have used jQuery data table here to populate all the sensor data here. Yep, that's end my demo. Thank you.